Okay, new chapter, chapter 3, 3.1. So the chapter 3 is about parallel lines and planes, the parallel lines and parallel planes. And in this section, we are learning definitions of different terminologies and concepts. And we have 3 objectives. So before we start, I want you to try to define parallel lines and skew lines the best you can. If you don't know, that's okay, using your own words. Okay, and stop the video, write them down, and see how close you come. Okay, all right. Okay, so here is chapter 3. We have definitions and properties of parallel lines, proving lines parallel, angles of a triangle and angles of a polygon. This is applying parallel lines to polygons. We are not doing 3-6, okay? And somewhere around here, we are going to, well, we definitely have a quiz here, okay? And this is probably most likely be the last quiz of marking period 1. I don't think we get to the test. And somewhere around here we end marking period 1. Okay? Alright, so these are the 3 objectives in this packet. So objective 1 is distinguish between intersecting lines. Make sure you write it down. Intersecting lines, parallel lines, and skew lines. Okay, so here are the definitions. All right, so we're gonna go over the definitions. These are parallel, okay? Line L and line N are parallel. And 2 lines that never intersect are either parallel or skew. So what's the difference between the parallel lines and skew lines? The parallel lines are coplanar. Skew lines are non-coplanar. Okay, that's the difference. Okay, so these 2 lines are on this plane, right? Let's call it I don't know, plane M. These lines are in plane M, and they never intersect, they're parallel. So these are parallel lines. And look at this one, let's call this plane N. Okay, this line is on plane N. This line is intersecting with plane N at this point and going through it. But since it doesn't touch this line when it goes through line N, these lines will never intersect. This is skew line. This is skew lines, K and J, and these are parallel lines, L and N. Okay, and the parallel and the parallel can be a segment, can be planes and lines and rays as well. Okay, so for example, line L is parallel to N. This is the parallel sign. Okay, but also the segment AB can be parallel to segment CD, or the line AB is parallel to line CD, or the ray AB is parallel to ray CD, and so forth. Okay, and skew lines, there are skew planes. So the skew can be segment, planes, lines, and rays as well. There is no sign for skew though. This is just for the parallel. There is no sign for skew. Okay, so here's some clarifications. These 2 segments are not intersecting, right? but if you extend them, they will eventually intersect. So segment PQ is not parallel to segment RS, okay? Even though they don't intersect, if they eventually intersect, they are not parallel, okay? Here is the 3D, the plane concepts, okay? So the plane X is parallel to plane Y, right? This plane is parallel to this plane, because they never intersect, okay? And if when we are talking about parallel planes, they don't have to be coplanar. We are talking about coplanar here for the lines, okay? When the planes are parallel, they can be coplanar, right? Likewise, the plane FGCB is parallel to plane EHDA. Plane EFBA is parallel to HGCD. You see that, right? Okay, so to think about skew planes. There are skew planes here. The skew plane actually do not exist. Only skew lines. I'm wrong. I'm sorry. Here. The skew planes do not exist. It's the segment lines and rays only, because if they are not the only plane that do not intersect the parallel planes, if they are skew, like for example, this line is skewed to this line. You see that? This line and this line will never intersect, but they are not coplanar. So line HG is skewed to line FB, for example. However, this plane and this plane are parallel, and this plane and this plane intersect here. Yeah, the plane eventually will intersect unless they are parallel. So there is no skew planes. Okay? All right. Okay, so here is some practice. I think it's pretty self-explanatory. You have to classify each pair of lines as intersecting parallel skew. And so you try this, you should try all this. Okay, so the 10, all this, and just do odds here. Okay. Let's try 14 together. Okay. Name two coplanar segments that do not intersect and yet they are not parallel. Two coplanar segments that do not intersect and then yet they are not parallel. Okay, so coplanar segments. So they have to be the segments in the same plane and well, the segments that do not intersect means, like for example, these HI and EF, they will eventually intersect here, but the segments are not intersecting, and they are coplanar, and they are not parallel. I don't like this problem. All right, let's look at because we just said the segments they are not parallel, they do not intersect. Yeah, they do not intersect. Yeah, so these are examples, like these are examples, right? These are segments that they don't intersect. Well, actually these are parallel, so that doesn't work. I think it's just these two, the MN and KJ, and HI and EF, and MN and HI are parallel. You see these are parallel and these are parallel, so I think that's the only pair. Okay, it's a little trick question because they do not intersect. They eventually will, but as a segment they don't, just like this example right here. These segments didn't intersect, so that's what this problem is asking. All right, let's look at 12. Name several lines skewed to GL. GL. Okay, so all these are parallel to GL. Okay, so 12. you have to look for the name several lines skew to GL. So GL is this one. Okay, so the skew lines, for example, AD is a skew, right? That's skew. And actually there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines in this diagram that are skew. So I want you to come up with at least 3 skew lines. Okay, that's also homework. Okay, all right, let's do these. The always, sometime, and never a good program to do. Okay. 2 skew lines are parallel. The parallel means they are coplanar and they don't intersect. And skew lines means they do not intersect, but they are not coplanar. Since you cannot be coplanar and non-coplanar at the same time, this is never. Okay. 2 parallel lines are coplanar. That's the definition, right? To be a parallel lines, they have to be coplanar, so that's always. Okay. A line in the plane of the ceiling and a line in the plane of the floor are, okay, sometimes. So I want you to think about what or when the lines are not parallel. I want you to think about that. If sometimes means it's not, they are not always parallel. So if when they are not parallel, what are they? That's a homework. Okay. 2 lines in the plane of the floor are 2 lines in the plane of the floor, askew. But 2 lines in the plane means they are coplanar. So they cannot be skew. So that's a never. Okay, all right, last one. A line in the plane of a wall and a line in the plane of the floor. Okay, so there's a wall and the floor. Okay, all right, can they be parallel? Yeah, they can be parallel. So that's, but if it's like this, it's not parallel, so that's sometimes. Okay, intersecting. Yeah, if they go like this and like that, they can intersect, but if they're like that, they don't intersect. If it's like this, they will eventually intersect. No, if it's like that, they don't intersect. That'll be a skew, but it's sometimes. Okay, and can they be skew? Yes, they can be skew. It's like, yeah, like this, and that will be a skew. So that's sometimes. Okay, all right. Objective 2. State and apply the theorem about the intersection of 2 parallel planes by a third plane. Okay, so that's theorem 3.1. 2 parallel planes, the plane x and y are parallel, cut by a third plane, the plane z, then the line intersection are parallel. So these are intersections, and these line L and line N are parallel. So that's a theorem. Now it kind of looks obvious, but you have to, when you can prove it, you have to prove it. So plane y, plane x is parallel to plane y. The plane z intersects x in line L, plane z intersects y in line L, and you're supposed to prove plane, the line L is parallel to N. So to prove this, you have to prove that lines are coplanar and lines do not intersect, because that's the definition of the parallel lines. So you want to prove this and this, then you can go here. Okay, all right, so L is in Z and N is in Z. So that's from the diagram, right? And also the plane Z intersects line in line L, the planes intersect in line N, so that's given. Okay, L and N are coplanar. That's the definition of being coplanar. If the two lines are in the same plane, they are coplanar. So you have to write it out, right? So if two lines are in the same plane, they are coplanar. Okay. L is in X, N is in X, and X and Y are parallel. That's given. And L and N do not intersect. That's like a definition of parallel planes. They are in the plane, and planes are parallel, so they do not intersect. So if planes are parallel, they do not intersect. Okay, and now we can say L is parallel to N because we say they don't intersect and they are coplanar. So if lines are coplanar and do not intersect, they are parallel. Okay, alrighty. Objective 3. Identify the angles formed by two lines are cut. No, when two lines are cut by a transversal. Okay, so that could be a new term for you. Here's the definition. Transversal is a line that intersects two or more coplanar lines in different points. Okay, so this is transversal right here. It's a T, because it's a line that intersects two coplanar lines in two or more different points. Okay, so that's a transversal. These are lines, and so this only works for the coplanar. If the lines are skewed, then it's not called transversal. Okay, so well, this is a 2D figure, so they are coplanar. But even if this was 3D, if the K is like this and H is like this, and there's a line going through, that's not transversal. Okay, and angles made by the transversal have special names. Okay, so here are the special names. The exterior angles are angles 1, 2, and 7, 8. You see those are outside and these are inside. So these are 1, 2, 7, and 8. Okay, and interior angles are 3, 4, and 5, 6. Okay, and also these are more important. Okay, these will come up a lot in this section. Same side interior angles are, these are same side interior. So interior angles are these, right? And they are on the same side of the transversal. So 3 and 5 are same side interior angles, and also 4 and 6 are same side interior angles. But 3 and 4 aren't, and 5 and 6 aren't. These are pairs, okay? These are all pairs of angles, actually. Alternate interior angles. So interior angles, right? Alternate means they are not on the same side. So 3 and 6. Alternate interior angles, and 4 and 5 alternate interior angles. Okay, and then corresponding angles are, just tell you which they are, 1 and 5. Okay, 1 and 5, 2 and 6, and 3 and 7, and 4 and 8. You see, it's the corresponding position. If you look at this is like a car moving on this highway, right? That's the driver's seat, that's a passenger seat, and that's a kids 1 and kids 2. So the driver to driver, passenger to passenger, kids 1 to kids 1, kids 2 to kids 2. Those are corresponding angles. Okay? All right. So here are some practice of naming the special pairs. So you have to do the corresponding angles, alternate interior angles, same side interior angles, angles that could name 2 pairs of angles that could be called alternate exterior angles. Well, you should try this. Okay, so this is homework. Even though this is not, we don't really use this, but try it. And classify each pair of angles as alternate interior angles, same side interior angles, corresponding angles, and none of these. I want you to do these all. Okay, shouldn't take too long. Okay, and I think we are done. Yeah, okay, well done.